What's up, everyone? Vin here, and welcome to the Algebra 2 Regents Review 2024. And yeah, once again, just thank you for joining me tonight. And I'm going to go through a full Regents. I'm going through the January 2018 Regents. Let me just check to see that I did not. Let me just post this real quick in the description. So yeah, let me go ahead and do that. All right, so here, I'll just right here is the test and not writing in all caps. Okay, and cool. So it should be updated now. So if you want to follow along, if you haven't already, well, yeah, I guess you wouldn't know until now that this is the one I'm doing. But this is the one that I'm going to be doing for the live stream. So hello, and I see the chat is very active right now. So yeah, before I get rolling here, I'll just say hi to some people. But very nice. Oh, I see people talking about AP classes. So Calc BC. What's the difference between AB and BC? Well, I mean, that's in your future, I guess, for, a bunch of you. So I would just, if I had to, I would say Google AP Calculus. Just Google this phrase. And if you look at the syllabus or the curriculum, they have a breakdown of all the topics. But Calc BC is really, 2 extra chapters. But the chapters are like pretty substantial, especially chapter or unit 10. So it's a good class to take, though, but not to be taken lightly. If you're going to sign up for Calc BC, you definitely have to mean business. It's kind of hard to just wing that class. So yeah, you don't need AB for BC. Yeah, I mean, you could just go right into BC and just, pace yourself. Cool. All right. But yeah, hello. Oh, thank you. You're the goat. I appreciate that. I'm just honestly just trying to, make as much quality content for everybody as best as I can. I like doing this Regents because I don't actually teach Algebra 2 at all. This year I taught AP Calculus BC and Geometry. But I mean, you have to know how to do this kind of algebra to be successful in calculus. So I'm definitely, confident with a lot of the stuff. I did have to brush up on like the probability stuff because it had been a while since I had seen it. But yeah. Oh, your final math Regents. So at RyanTube HD, hello again, and I appreciate the vote of confidence. Fortnite, Sweaty Kid, hello. This is what did you think of the geometry Regents? Yeah, because I know you're taking both, right? So very cool that you're going ahead like that. My favorite algebraic structure. I mean, that's a really good question. My favorite algebraic structure. I mean, I'd have to think about. Oh, thank you for the tip at Leroy Johnson. Thank you so much. I appreciate the tip here. Yeah, thank you. I'm, humbled to have this many people on, and now, tips as well. It's really nice of you. So thanks. I don't know. I'll just say Pascal's triangle is pretty fun. There's a lot of math packed into that. That's like, you could really, get a dive out of. So that one's pretty fun. You don't use your calculator much in Algebra 2. I mean, you can. It's definitely, I'll show you as many tricks as I can with the calculator. I'll show you like, oh no, I'm afraid of how to, solve this by hand. So, yeah, what's my favorite math topic? I mean, I would say like probably anything challenging. Like when I'm doing calculus, I like Unit 10, the Maclaurin and Taylor series unit, because it's the most challenging, but it's like the most satisfying when I see my students figure it out, because it really like challenges them to just persevere and to keep at it. And then in geometry, it would probably have to be proofs, because when I see a student really, struggle and then they finally get it, it's more rewarding the more challenging the topic is for the teaching side. This live will be as long as it takes me to get through this test. So probably 2-ish hours. Do you need an 80 or above on a math Regents to get into college? No, you could get into college with a lesser grade, but at Catherine, I would say you want to get an 80 and above just so that you could show up to college math ready. because the grade you need to get into college is not the grade I would say you need to be successful at the college level. If you're going the STEM route, if you're not going the STEM route, you need one math class in college, and it shouldn't be like the worst to get through. But if like you just make it by to graduate, then the math might be challenging to get through that one math class. So I would say it's worth your time to get good at this. I hope this review is going to be good for tomorrow's exam. I'll try to cover as much as I can, but it's, probably the last few regions, the videos that I put together. I did, what's it called? I've done January 2024 and like a bunch of the regions before that. You could check those out in addition to this. So yeah, I was a math major. Yeah, so I majored in math when I was in undergrad. So I'm glad I did, because teaching math, you don't have to be a math major to be a math teacher, but I'm glad I went like really heavy into math. Like a lot of heavy proofs. Oh, at Dave Braun, thank you so much. I appreciate it. So, all right, well, here we go. We got 200 people here. It is 8 o'clock. So I guess I'll start answering questions. I'm doing the part ones, and they are worth 2 points each. Now, right away, right before your geometry test, you slept for 3 hours and you crushed. Very nice. I'm glad you showed up ready and you felt very confident leaving. So very nice. I'm happy to hear like people doing well. Hard work paying off. Alrighty. So let's see. Oh, favorite course from undergrad. All right, real quick, last one. So I'll say combinatorics and graph theory. It was the same professor for both classes, and it just really opened up my eyes to just how deep math goes. Like you could spend 4 months on just the unit circle and you still don't know everything about the unit circle, like that kind of stuff. So the professor, I give all the credit to. He was just absolutely amazing. So, but all right, algebra 2 times. So here we have the operator of the local mall wants to find out how many of the employees make purchases in the food court when they are working. She hopes to use these data to increase the rent and attract new vendors. In total, there are this many employees who work at the mall. The best method to obtain a random sample of the employees would be to survey. All right, well, this one, all of the employees at each of the large stores, no, because that's too specific. That's not random if they only work at the larger stores. 50% of the 90 employees of the food court, well, no, they work in the food court, so that's going to create bias. Now, this question I thought was like a little annoying. It actually, in this one here, it works out to choice 4. You might think like, oh, but every employee would just give you the best idea. But we want to obtain a random sample. We choose every employee. That's not very random. Okay, so that's why, yeah, that part. But every 30th employee entering the mall entrance, every 30th employee entering each mall entrance for 1 week, that's pretty random. Okay, because we don't know which employee we're going to get here. So that one I thought was like not as nice as it could have been, but yeah. All right, so this, I'll show you the algebra and I'll show you the calculator. So how do I do this on the calculator? Well, what I would do here, let me just move this so that I'm not wasting any space here. And if we look, so if I go to y equals and I put the left side, I have square root of x plus 1. I get out of this, I press -1. That's the left side. And then the right side of the equation, I just write x. Now I press graph. And I'm going to show you a little trick. Zoom box. Zoom number 1. So I really just care about what's happening in this neighborhood here. So I'm going to, just like I'm cropping a photo. Okay. And we look here. Now, this is where the calculator might deceive you. Like, oh, wait, what's happening at -1? So if we look at the table here, see at -1, the y values match. Okay, so x equals -1 is a solution. And then notice when x is 0, the y values are both 0. So -1 and 0, choice 3, would be the answer just from using the calculator. Okay, so if the graph doesn't do it, then the table will make up for it. All right, so that's if you just want to use the calculator. But look, this is the algebra Regents. If I don't show you how to do this algebraically, I feel like that's kind of cheap. So I will do that now. All right, so here I have the square root of x plus 1. minus 1 is equal to x. So I just go plus 1 on both sides. Okay, so this is the technical way if you don't want to just use the calculator. Which I think it's good to see this because if they put this in the free response, using the calculator will get you half credit, but if you do the algebra when they tell you to do it algebraically, that's going to get you the full credit. So here I get the square root by itself. And then to break a square root, you would square both sides. Okay, so let me just change colors here. So I'm going to go square the left side and square the right side. So now the square root of x plus 1 times itself is just x plus 1. And now this, please don't say x squared. Please don't say x squared plus 1. Okay, that's the most common mistake. There's going to be a 2x in the middle. All right, reason being, when you do x plus 1 squared. Oh, at no arrows, thank you so much for the tip. I have 2 monitors. I'm doing my best to monitor the chat as I write, but yeah, thank you. Much appreciated. So here, x times x is x squared. X times 1 is x. Distribute, I get 1 times x is x. 1 times 1 is 1. So that's where that 2x is coming from. Now, from here, I need to move everything to one side. So I go minus x, and I go minus 1. Okay. So now cancels, cancels. 0 equals x squared. 2x minus x is x. 1 minus 1 is 0. These just cancel out. So here, I could factor out the greatest common factor, which is x, and I get x times x plus 1. And then I set each of those factors equal to 0. I could set x equal to 0. That gives me one answer. And I set x plus 1 equal to 0. And that gives me x equals negative 1. Okay, so there are the 2 answers. Now, I'd have to plug back in to check. And I'll just plug one of them in for now. Like if I plugged in negative 1. Let's see, I just replaced both x's with negative 1. This gives me the square root of 0, which is 0. And 0 minus 1 equals negative 1 is definitely true. Okay, and if I plug in 0, I'm going to get square root of 1 is 1, minus 1 is 0. So that, like, they both check out. Okay, so definitely 3. Choice 3. All right, now this one you could do by hands, or you could use the calculator. That's up to you. If you use the calculator, though, I mean, all right. So let's say you want to use the calculator. This one, I would just move the 2x, the minus 2x to the other side. If I did plus 2x, I'd have 2x plus y equals 14. Okay, I have 3x minus 4z equals 2. And then I have 3x minus y equals 16. So if I just put it in standard form, this system, then I could go to the calculator. And let's just see. I go to apps, number 9. And let's see, simultaneous equation solver. So that is number 2. Okay, not the help, that's the help option. I have 3 equations, and I have 3 variables that I don't know. And I press next by pressing graph. And now I just input this. So I have 2x. I press enter to keep it plus 1y, 0 z's. I just press enter, equals 14. Okay, now I type in the second equation, 3x. Now minus, I'm going to press subtract. So minus, I'm sorry, there's a 4z, but plus or minus 0y doesn't matter. Still, if you add 0 or subtract 0, it's the same thing. So now I have minus 4z equals 2. And then the last equation is 3x minus 1y plus 0 z's, there's no z term, equals 16. Now I press solve by pressing graph. And I get, let's just see, I'll just copy and paste this. So, moment of truth. So we have these values here. So yeah, if I don't feel like doing the algebra, just want to use the calculator, this is how, use the calculator. I've heard some people say like, oh, when they reset the calculators, doesn't it eliminate that? Well, if you had to do this by hand, you want to solve for the value of z, then what I would do here is, let's see, target probably one of This one already says y equals. So if I had to, I would substitute into this one. Let's see. So algebraically, 3x minus y equals 16. And you see y, I would plug in negative 2x plus 14. So if I do this, this is 3x. If I distribute the negative, I get plus 2x. And then minus 14 equals 16. And then from here, plus 14 on both sides. Whoops, I don't know what just happened there. We'll just make it work. And then 5x equals 30. So x is equal to 6. And then once I know what x is, I could plug it into the second equation here. So I'd have 3 times 6 minus 4z equals 2. So if I had to solve it by hand, I just have to just target one variable at a time. Okay. And then from here, I mean, we're getting, choice 4 because we want to know what z is. But then this, we just do the algebra. We do minus 2 to get 16 plus 4z. So this tells us z is equal to 4. All right. Either way, we're getting the same answer. All right. Cool. All right. Moving on to calculator again. So we have the hours of daylight, y. So just pay attention to that. The hours of daylight is y. And then we have in X days from January 1st, 2013. Can be modeled by this function. How many hours of daylight to the nearest tenth does this model predict for February 14, 2013? All right, this is a little annoying because you got to do some calendar math. So I'm like, all right, not nice, but January has 31 days. Okay, so here, what I'm imagining is that to get from 1 to 31, from January 1st to January 31st, that's plus 30 days. And then the next day would be February 1st, and then we'd have to go 14 days from there. Okay, so we're going 30 days, and then we're going 14 days. So plus 30, and then to go from 31 to the 14th, we're going, forward another 14 days. So here, what we could do with that information is we just plug that into the calculator. Okay. So yeah, a little bit annoying like that. Like we have to kind of resort to this. Like I thought that was kind of like an unfair question because I'm like, all right, plus 30 makes it the 31st and then plus 1. I mean, you could just then count. You could say, all right, plus 30 makes it the 31st and then 31 days will make it the 1st and then 2nd, 3rd, 4th, 5th, and so on like that. Okay, so, but let's see. Let's plug this in the calculator. All right, so y equals, make sure you're in radians also. So let's say second memory 712, the calculator is reset. And then we go 3.06. So 3.06. Then sine of 0.017x minus 1.40. Okay, just make sure I didn't make a typo. And then plus 12.23. All right. Now from here, remember I said like, going forward 30 and then going forward to the 14th. What I could do is I press second graph, I go to the table, but I have to scroll really far to get to 40, like in that range. So what I could do is I could switch the calculator from auto to ask. So what I did was I pressed second window and that brought me there. Okay, so second window puts you here. And now my table is blank. So then if I just start typing in stuff like, let's see, 40, 41, 42, 43, 44, 45, and so on like this. All right. So we look here and we borrow these values and just see. Like, even if you were like struggling a little bit with that calendar math, like me, honestly, I have 3 hours. I'm going to spend a little time double checking that I'm in the neighborhood. But you could see here, even if you're debating like, oh, wait a minute, am I doing plus 30 plus 14 or plus 30 plus, you could see that 10.4 is the most reasonable answer out of all of these. Okay. But you could see that when we do, 30 days to get here, plus another 14 days. So you might be thinking like 44 or is it 45? But either way, 44 or 45 rounded to the nearest tenth is putting you at 10.4. Okay, so they're usually like a little bit forgiving here to not make it like so annoying to do. All right, cool. But yeah, that little table trick is nice. All right. So this one, if you really understand exponential functions, then you might just be able to think about this in your head. But otherwise, you're always like welcome to graph this. So either way, but let's see. We have a pain reliever is taken in 220 milligram doses and has a half-life of 12 hours. Here's the function A that could be used to model this situation where A is the amount of pain reliever in milligrams in the body after T hours, which makes sense. You take medicine, it starts off and then like it starts to decrease over time in your body. You wouldn't want it to increase over time because then you would just have too much medicine in your body and that would just be terrible. Your organs would give out. Okay, so it has to be exponential decay. So here's A and here's T. So the 220 represents the initial amount that's in your body. And you can even see that if you plugged in T equals 0, you would get 220 times 1/2 to the 0 power. 1/2 to the 0 is 1, so this just makes 220. And then it just decays over time. So now, let's just see. In 12 hours, there's no pain reliever remaining in the body. Well, this one, remember, they said every 12 hours is a half-life. So the amount is divided by 2 every 12 hours. So here, there's no pain reliever, no pain reliever. It's like out, out. Okay, like just those answer choices make the least sense. Every hour, the amount of pain reliever remaining is cut in half. Well, they said it has a half-life of 12 hours, which means it takes 12 hours for the amount to be cut in half. So just by process of elimination, it has to be this. Okay, but let's see. If we want to use the calculator, you don't have to use the calculator for every question. Like if you want to start trusting your math, saying like, you know what, I know how these functions behave. I don't need a calculator. Then don't use a calculator. Okay. All right. All right. So here's this. Now I press graph and I'm like, oh no, I can't see anything. I'm going to press second window and put it back to auto. And I say, why can't I see anything? Because this thing starts at 220. So this, I would go to the window and I would increase the max to like, let's say 250. Now I could see. All right. But then maybe I want to go out more because it takes 12 hours to cut in half. Let's say I go out 120 hours. Now we get a better idea of what's going on. Okay. So now let's look at that last answer choice. In 12 hours, 110 milligrams of pain reliever is remaining. So 12 hours, I'm going to scroll to 12 and see there's 110 left. So, yep, that makes sense. Cool. All right. So this one, be careful with these questions. Which the expression can not be written. That means that 3 of them are right and 1 of them is wrong. So for something like this, I don't know. I would just start by distributing here. So I would see like, all right, x times x is x squared. And then x times b is xb. And then a times x is ax plus a times b is ab. So the one that's looking bad right away is choice 2. Because xb plus ax, these I would do x times a plus b. See, like, let me write that underneath actually. Like if I were to combine those terms, I would add the coefficients of x, not multiply them. Okay, like imagine if you had like 2x plus 3x. The algebra that's going on here that no one ever writes is the distributive property, backwards. If we factor out the x, then we're left with 2 plus 3, and that makes 5x. That's like what goes on for something easy. Okay, so this is like when it's easy. Okay, this is not as easy. But what's going on here is I'm doing, b plus a. Or I could say a plus b times x, and then plus ab. All right, that's why this one's out, because that's exactly the same thing. Okay, this one's not it because they multiplied instead of adding. All right, you might be saying, well, how about this? Well, if we group this stuff together, like let's say for choice 1, if I did x squared plus xb plus ax plus ab, I could take out an x and I'm left with x plus b. Plus I could take out an a and I'm left with x plus b. And then I could just flip these two. That's why this is not it. And then something similar eliminates this one. Alrighty? All right, so moving on here, I'm going to, normal CDF. Because we have 440 students at a high school. On the April report card, the students' grades are approximately normally distributed. And they give us the mean, the standard deviation, and the students, we want to know the students who earn a grade less than or equal to 64.9 must attend summer school. So how many kids are going to summer school? Approximately. All right, so here I'm going to go second mode to quit, and we're going to press second vars and normal CDF. So this is kind of like the section of the data. So think about this part. Students who earn a grade less than or equal to 64.9. So let's say a kid gets a 0, but the highest they could get and still go to summer school is 64.9. They got less than a 65. All right, now this part here is the average. Okay, the mean is 79 and the standard deviation is 7. And now we just press enter and we get this here. But now this is the kind of like the percentage of students that got less than a 64.9 given this data. But there are 440 students at this high school. So if we take that percent of 440, this is the approximate amount of how many kids are going to summer school, 10. Okay, so 10 kids failed, which I guess isn't that bad. It's pretty high passing rate. All right, cool. So that's what's going on here. And let's just see, that rounds up to 10. Now, one thing I want to point out is if you're like, what on earth just happened? What does that mean? Remember, the calculator just does the magic, but the concept. So here is the concept. Is that this is the average, okay? They're saying the average is a 79. And the standard deviation, so 1 standard deviation, 2, and it's a standard deviation of 7. So if I do 79 plus 7, that's 86. And then plus another 7 is a 93. If I go minus 7, I get 72. Minus another 7 is going to put me at 65. Okay, so you could see here, like learning the middle 95% is plus or minus 2 standard deviations. So this is like this whole space here. That's the, this is the middle 95%, plus or minus 2 standard deviations. So the kids who failed with less than a 65 is like this tiny percentage here. Okay, you see how it's almost like 2-ish%. So it's like 2%-ish here, 2%-ish here makes the total 100. Okay, so that's the concept of what's actually happening. But otherwise, just let the calculator do the magic and you'll be fine. Cool. Alrighty. So next up, let's see. We have, for a given time x in seconds, an electric currents. Let me just follow in my notes because I solved this ahead of time just so that my explanations are smoother instead of like doing everything from scratch. So we have, for a given time x in seconds, an electric current y can be represented by this. Which equation is not equivalent? See, these are like one of those word problems that are like anti-word problem. Like, why not just say, here's an equation, which one is not equivalent? But whatever. All right, if you don't like doing the algebra by hand, you could graph this and the 4 answer choices. And which one is not equivalent? By the time you graph this one and the last one, that would be it. But how do I know? Well, let's just see here. For this one, all right, first thing they did was distribute. So if we distribute, so I'll write that result over here. Y equals 2.5 times 1. And then 2.5 times this, we have 2.5 times a negative, so we have minus 2.5, and then times that 2.7 to the negative 0.10x. All right, and then the next thing they do here is, the power to the power rule. So a to the b to the c is a to the b times c. So this one, all they did was they cut this in half. And if you cut this in half, that's negative 0.05. But you could see here that if you did just this times this, 2 times negative 0.05x is negative 0.10x. So the first two are equivalent. All right. And then this one here is the same as this one, except this idea. A to the negative b is 1 over a to the b power. So they just took this piece and they wrote it as 1 over 2.7 to the 0.10x. So process of elimination, it has to be this one. The problem, why is this answer choice no good? Well, they're using this property. A to the b times a to the c is a to the b plus c. So when we multiply this by this, we should get 2.7 to the negative 2 plus 0.05x. And that does not turn into this. Okay, if we multiplied them, then yes, but wrong property. Okay, but you could also just graph this, and they won't match. All right, so, if I was like, oh no, I'm nervous, I don't know if I trust my algebra, then the calculator will save the day. If you know how to use the calculator well, you'd be surprised like how much that could do for your score. Okay, so negative 0.10x, making sure I wrote it right. Cool. And then if I write the wrong answer, was 2.5 minus 2.5, whoops, let me just fix that, 2.5 times 2.7 to the negative 2, and then 2.7 to the 0.05x. Okay, and if I look at the table, see how they don't match. All right, so those are definitely not it. If I had switched it to, let's say, I don't know, I mean, even this one, then let's just see. So this one, I get rid of this. So 2.7 squared, and now I'll just delete all this stuff. Wait, hang on a sec. Yeah, see, this is like, okay. So 2.7 squared to the negative 0.05x. That should be the same. And they match. Okay, so that's how, just type in the answer choices also. Okay, this one here, I would do, I like polynomial division. So I like polynomial division because sometimes synthetic division fails. And if you're kind of fuzzy on when it fails and when it doesn't fail, then yeah. Oh, hello to everybody. So I'm going to keep rolling here. So 10x to the third minus 3x squared minus 7x plus 3. And let me move this over. Okay, and I'm dividing by 2x minus 1. So I just go term by term here. So this, I'm dividing by this. And that's going to give me 5x squared. They all start with 5x squared, so that doesn't really eliminate anything. So then I multiply. This times this, minus 5x squared times 1 is 5x squared. But here's where people mess up. Please make sure you subtract. And when you subtract, a little shortcut is when you distribute the minus, it just changes the sign of everything. So I could just say minus this. So I'll put that in a different color. I could go minus this and then plus this. These terms cancel. Negative 3x squared plus 5x squared is 2x squared. And then the negative 7x comes down. And then I focus on this one and this one. Okay, so now we find the next term here. So when I do this divided by this, Now I'm just going to get plus x. All right, and now this should start to eliminate things already. We should be getting plus x. So these two are out. Okay, so these two are out. And now we're left with the next stage here, which is to multiply. So we have x times 2x is 2x squared. And we have x times minus 1 is minus x. And when we subtract, shortcut, just change the sign of everything. These cancel, and then negative 7x plus x is minus 6x. I bring down the 3. Now, negative 6x divided by 2x, that's going to give us minus 3. Okay, which I could just see right away has to match this one. Now, if I distribute, negative 3 times 2x is minus 6x. Negative 3 times negative 1 is positive 3. So this stuff just cancels out nicely. When we subtract, we have no remainder 0. Okay, you could also just take this and then do times all the answer choices and see which one gives you something that matches this. All right, so calculator will also work. All right. All right, let's just see. So this one, Judith puts $5,000 into an investment account with interest compounded continuously. Okay, so compounded continuously is Euler's formula. So this one here, aperts. All right, we call it Euler's because that exponential term is named after Euler, Leonard Euler. He's basically the goat of math. So he's a really impressive guy to have a number named after him. So this is what we're going to plug into. So Judith puts 5,000. That's the principal amount. And what is the approximate annual rate needed for the account to grow to this after 30 years? Okay, so this would be A. And this is the time. And this is the principal. So here you just plug in. So we're going to have 9110 equals P is 5,000. And then we have E, I'll make that neater, to the R times T is 30. All right, now this one, if you don't like doing the algebra yourself, well, what you could do is just calculator this. All right, you could just do, let's see, Y1 is 9110. And this side is 5,000. E to the 30R, but we're going to use X. And then you press graph. I'm going to press zoom 6 to put it back to normal. And you might be thinking like, oh no, I can't actually see anything. Okay, I don't see a thing. And that's the reason. The reason is we have to hit 9110. So my window, I should go up to, let's say I go up to 9200. Okay, now I could see the intersection. Second trace 5, no, not 6. Second trace 5 is intersect. And I just press enter 3 times. And it's going to be here. Okay, so that's if I don't want to do algebra. You're in the multiple choice. So if you really want the calculator to do all the algebra for you, you can, but if you don't know how to do this for the free response, then that's going to hurt your score. All right, but if you're just looking to pass, not that I'm going to condone that, oh yeah, just try to pass. Don't ever try to do anything better than that. Then but realistically, the test is tomorrow morning. This is a nice trick to know. Okay, so R would equal 0.0199 like this. So it's basically R is roughly 0.02, which is the same thing as 2 out of 100, which is the same thing as 2%. Okay, so 10 is choice 1. If you want to do this by hand, all right, you're like, wait a minute, what if they give me a log or an exponential equation in the free response and I have to do this algebraically? Then you're going to get the E term by itself. You divide by 5,000, okay, on both sides. Want to make life a little easier, you could get rid of those trailing zeros. And now you have 911 over 500 equals E to the 30R. And from here, you just natural log both sides. Natural log and E cancel. And I'll write it over here. Sorry, it's zigzagging a bit. Actually, I could squeeze it here. Now I have 30R left on the right equals natural log. I'll put this in parentheses of 911 over 500. And then just divide both sides by 30. All right. And that expression should give us the same exact thing. Moment of truth. Otherwise, math is broken. Okay. So let's see. Divided by 30. And it is. Same thing. 2%. All right. You want to turn a decimal to a percent, just do times 100. And that's like almost 2. So 2%. All right. So let's see. Question 11. I need to take a drink. This is, let's see, Izzy's Sparkling Apple. I feel like they should send me a free case. 443 people watching, right? All that free advertising. All right. All this talking. Oh, yeah, and if you haven't subscribed yet, I would appreciate, helping me grow the channel. Although, like, it's been really cool just seeing the channel just kind of grow organically on its own. I don't really do a ton of that, like, hey, subscribe stuff. But if you haven't, I would appreciate it if you're finding this helpful. All right, cool. So now, let's see. N equals square root of a to the 5th. M equals a. N divided by m. So n over m is this. Divided by m is just a to the 1st. Now, what you have to know here is power over root. There is an invisible, so this is the one root that is invisible. There's an invisible 2 here. And just know this idea, that the c root of a to the b is the same thing as a to the b over c. Okay, we put the power over the root. Okay, power over root. But there's an invisible 2 with square roots. So this is a to the 5 over 2 divided by a to the 1st. Now, more law of exponents. A to the b over a to the c is a to the b minus c. This gives us a to the 5 halves minus 1. And then this is the same thing as like 2.5. So this will give you a to the 1.5, which is the same thing as a to the 3 over 2. And then more power over root. That's a 2. Don't say 2 root. We say square root of a to the 3rd power. All right, so that's this one. If you're like, wait a minute, I don't like fractions, they scare me, then this is what you'll do. 5 over 2 minus 1. And then press math, enter, enter. Okay, and you get 3 over 2. Awesome. All right. More stuff here. So this one, you could just do second trace 5 again. That'll work. Should we do that? I don't know. Let's see. Yeah, I guess it depends on your mood. Like if you feel like doing quadratic formula, you can. But this one, you could just use the calculator. Like watch this. This should be illegal, this trick. But like, let's say I go like this. I'm going to show you alpha y equals enter makes a fraction. 3 over 2. Someone told me a shortcut, like on my calc live stream. I might have forgot it. I think it's just like alpha F4, maybe. Maybe that was it. Not alpha trace. Wait. Alpha something. Oh, I have to rewatch that. I'm sorry, whoever told me about that. Hope they forgive me. Okay. So square root of 17 and then over 2. So let's say I'm like, oh, I like this number. I type in the root. I press store alpha math. So that way I only have to write the letter A and it'll keep writing that number. So now watch this. A plus 3 minus, yeah, this trick should be illegal, but it's not. So you should use it. Okay. Ooh, 5. All right, so it has to have 3 over 2 plus, so automatically 1. Yeah, that's like pretty nice that it works out to that. All right, and then if you want to check the other one, then, you could do that. Like you could go like this, change this to minus, store this. This is the new A. And then you could just recopy this. Still 5. All right, so definitely 1. All right, cool. Very nice. But of course it's algebra. And if I just show you magic, that wouldn't be fair. So here, the other way is to do the least common denominator method. So the least common denominator is x minus 1. It's the only denominator other than 1. Like these all technically have invisible ones. So what I would do is I would multiply this whole equation by x minus 1. X minus 1 times this. Okay, this is if I had to do it by hand. But if you have the calculator, like honestly, multiple choice, it's like you're going to check your answer anyway, so you might as well. So I distribute, I'm going to do x minus 1 times the entire x plus 3. I could do x minus 1 times x and then 3, but I'll just do it to this like all at once. Okay, and then minus x minus 1 times 4 over x minus 1 equals 5 times, so I did it times this, and now I distribute it to the last one. Okay, so now algebra skills, x squared, that's plus 3x minus x, which is 2x. And then minus 1 times 3 is minus 3. X minus 1 over x minus 1 cancels. And then minus 4 equals, we distribute, and we get 5x minus 5. You see how much extra work this is? I don't know. It doesn't seem really worth it. Unless they tell you to do it algebraically, then you have to. Okay, so then we do all this, and then we have to use the quadratic formula. So yeah, this is like a lot of work. X squared minus 3x. This makes negative 7 plus 5 is negative 2. Okay, so now we get here, and then we would use the quadratic formula. So I'd have, like, this is my b term, my c term, and the 1 is my a term. So I'd have negative b, which is 3, plus or minus the square root of, and negative 3 squared minus 4 times 1. So 4 times 1 times negative 2, all over 2 times a. So this is just using the quadratic formula. And let's see, 3 plus or minus the square root of, that's 9 plus 8. And 9 plus 8 is 17. And it's all over 2. Okay, and then I just break this up. I do 3 over 2 plus or minus square root of 17 over 2. So it's the same thing. So much work. So yeah, so don't do that. All right. Oh, let me see. Is everyone behaving in the chat? I had to kick out, like, the last geometry live stream was like a record for throwing people out. So please be nice. That's like the one rule I care about. Be nice to each other and me. Same rule in person when I teach in the classroom. I just want people to feel comfortable here. All right. And mods, you could, if you want, not to give you too much of a job, but if anyone's not nice, you have permission to put them in the, to silence them. All right. Yeah, I mean, you could still be here. You just can't type anymore. So for people that love to troll, that's a good enough punishment. All right. So A, B, and C are positive. Wait, what do we? Oh, solve for t. Okay, so we have this equation. A, B, and C are positive. What is t equal to? So t is, yeah, over here, that piece. All right. So this one, and let me get some space. And how are we doing on? Oh yeah, this. I guess we're making decent time here. So a e to the bt equals c. Now this is not like these terms here for now are like all connected. Like e to this power, I can't just like divide by b. I'd have to use logs. That's why all this has natural log. So first I would just divide by a. Now this is gone. And now we have e to the bt equals c over a. The opposite of e is natural log. So the reason I'm doing this is we are solving for t. Okay, so that's what we want. So we want to just start doing the opposite stuff until stuff cancels. Natural log and e cancel. So now we have bt equals natural log of c over a. And then to solve for t, just divide by b on both sides. So t equals this mess. And that looks like that's choice 3. Yep. Cool. Yeah, this one calculator. So they're giving us a job on the calculator. One cool thing though about absolute value that people might not know. Y equals x looks like this. And wait, we could do better than that. There we go. Y equals absolute value x. A nice way to think about it is that absolute value takes negative stuff and makes it positive. So you see here, like this part of the graph is negative. So it makes it positive by flipping it up. That's why absolute value x looks like this. Okay, so if you think about something like x squared minus 9, so this piece here, x squared minus 9, I think of like, okay, so it looks like this. So there's x squared minus 9. It has roots at plus or minus 3. So minus 3, positive 3. So if I were to throw this in absolute value, so let's say I call this just f of x. This is just a concept. All right, you don't have to do this, but if I were to throw this in the absolute value, it's going to take this, and instead of going under and making a u, it's going to bounce up and then do this. Okay, so that's what the absolute value of x squared minus 9 looks like. Because it takes the negative stuff and it flips it. The positive stuff stays positive, but the negative stuff flips. Okay, so if I take this and then I go down 3, that's just going to take, like, this is technically going up to 9. It's going to shift everything just down 3. All right, so I'm just kind of imagining what this thing looks like before I graph it. But look, we have a calculator, so we're going to use it. All right, so y equals math, go to the right. Absolute value is number 1. X squared minus 9. We get out of there, we press minus 3. Equals math, go up to option A. We're doing log base 3, okay, of x. I'm going to press zoom 6 to put everything back to normal. And we have 1, 2 points of intersection here, okay? If you want to go zoom box here to make it a better window, like I could scroll, I press enter, and then it's like cropping a photo. Right, maybe you know that trick, maybe you don't. All right, I did show it before, but there it is. So now it's easier to press second trace 5. Oh, Adamira, thank you so much. I appreciate the tip. Thank you. And if anyone else sent one and I just didn't notice it, I'm sorry, but it kind of lights up, so it does catch my peripheral vision. So this is the first one, and then second trace 5, and I get the second one. Alrighty, awesome. Hang on, I could do this. So now I just identify the x values here. Sorry, this got like kind of chopped. Oh, there we go. So it would be x equals 2.29, which I think right away just makes it choice 1, but also x equals 3.63. Okay, so second trace intersection. All right. Oh, physics. More, but yeah, physics. I used to teach physics for 2 years. You know, I played with the idea, maybe in the future I'll start doing physics ones, but I'd have to relearn it. I haven't taught physics in 5 years, but because there's like teacher shortages, there was a science teacher shortage at my school. So they're like, hey, like you teach calculus, could you teach physics? And I was like, yeah, sure. Like I was a fairly new teacher, so I taught it. But that one, just know it's all on the reference sheet. Like I'd say like 70% of the Regents is on the reference sheet. And then like the rest is just concepts. So actually, no, maybe like 50, 60%. Maybe I'm being too dramatic here. All right. So some physics. You want like a physics brain break? I just say something about physics. I mean, I don't know. It's a lot of math skills for physics. So that's why I said I would teach it, because it's like this heavy word problem. But yeah, don't psych yourself up too much. So this is in quadrant 3. Oh, this is helpful. Ready? ASTC. What does this mean? It means all students take crack. No, this means all sine, tangent, cosine. So all of the trig functions are positive when you plug in an angle from quadrant 1. Okay? At amanatic, if I'm saying it right, amanatic. Sorry, phonetic sometimes. But thank you for the tip. I appreciate it. This chat is like really nice. I appreciate you. I appreciate you all so much for like this. So far, so good. Has been like the nicest chat. I don't know. Sometimes I think like algebra 2, like students are like, like junior year, senior year, like you mellow out the most. But yeah, geometry was like off the rails. Like it was kind of nuts. I was like just like mute. I mean, there were a lot of really nice kids, but like the trolls came out in like full force that day. Like it was. I grade the Regents on Monday, Tuesday. I didn't grade over the weekend because the test was just Friday, and I actually had to proctor it. So, all right, let's see. So for one, why do I bring this up? Secant theta is the same thing as 1 over cosine theta. And this is a quadrant 3 point. So if we're talking about a point that terminates in quadrant 3, only tangent and its reciprocal are positive in quadrant 3. So tangent theta and cotangent theta would be positive here. But since we're talking about secant theta in quadrant 3, that means it's going to come out negative. So, and all these answers are negative. So that was a little silly for me to talk about that. But hey, sometimes you could eliminate answer choices with that. So I guess I'm at peace with that. So this is X and this is Y. And let's just see. We're on the unit circle. So that part is nice. So what I like to think of is I plot the point. So negative 1/3 and then negative square root 8 over 3. So just we have a circle. So let's just say, yeah, sure. Like that's our circle. All right. So here, if this is negative 1/3, comma, negative square root 8 over 3, what I imagine is, how do I get there? I go to the left and then I go down. Okay. So this distance over here is 1/3. This one is square root 8 over 3. And this distance, they told us we're on the unit circle. So it's 1. Okay. If you wanted to run it through Pythagorean theorem, you're still going to get 1. The reference angle is here. Okay. The reference angle is the positive acute angle. So I'm just going to say reference angle is positive and acute. And it is formed using the x-axis. So it uses the x-axis and the terminal side of the angle. The angle theta from standard position, like this angle, let me draw this in a different color. Like this entire angle is theta. But the reference angle is the positive acute angle between the x and the terminal side. Now, how is that helpful? Well, if I want to find what secant theta is, secant theta is the same thing as 1 over cosine theta. Okay, but what I could do here is I say, oh, I'm in quadrant 3, cosine is negative there. So I could go negative 1 over, and then I do cosine of the reference angle. And cosine of the reference angle over here, if I just treat this as a normal triangle, is adjacent over the hypotenuse is 1. Okay, so just remember SOHCAHTOA back from geometry. So cosine of the reference angle is 1/3. So I have negative 1 over 1/3, and then this simplifies to negative 3. Okay, so 15 is choice 1. All right, there's one formula sheet I want to give you for the next question. Oh, let me see. Yeah, this is the one. I'm going to put something in the chat. So if you want like a nice cram sheet, maybe it's a little late in the game for it. Okay, it's like from the Regents people. But what you could do is if you just want to have things memorized, it'll tell you how to deal with this focus directrix stuff. It's kind of late in the game for me to teach you the proof of the focus directrix formula, but that's how I understand this stuff. Okay, that P, they talk about the distance between like the focus and the directrix as being P, but I show you like kind of the concept way. I can't memorize the formula. I only know how to like derive it, like prove it, and I know the concept. So the concept that you need for a question like this is that any parabola is the set of all points that are equidistant from the focus and the, let me make this neater, and the directrix. So what we mean by that is if I take any point here, xy, the distance from that point on the parabola to the focus, so this distance here is always equal to this distance here. Okay, so I'm just going to move this up a little bit so it's like a little bit more realistic. Okay, so yeah, so like that. All right, so then that is the concept of what a parabola is. So the focus is like inside the parabola. All right, because I could also just take this and I could flip it upside down. All right, like if I group this together and then let's see, I rotate it. See, the directrix could be above and the focus could be under for the sad parabola. But just know, like, it's like, I almost think of it as like the parabola is kind of like a bag of some sort, and the focus is like inside the bag, right? Like drawing it out like helps me remember. I can't, it's hard to remember like every formula from every math class, so I have to understand why it works. Okay, so here, what is the equation of the directrix for the parabola given by this equation here? Well, for something like this, what I'm doing is I'm either going to use the formula for like the formula sheet that I gave you, or I'm just going to solve this for y. So I would divide by -8 on both sides. And that's going to give me y minus 3 equals, if I divide by -8, that's -1/8 x plus 4 squared. Okay, and then this, if I do plus 3, gives me y equals -1/8 x plus 4 squared. So we have x plus 4 squared and then plus 3. So if you know the formula for the vertex form of a quadratic, it's this. Okay, so there's the vertex form, and the vertex is hk. So our vertex, so the vertex we have here is going to be -4, 3. And it's an a value that's negative. That means it's a sad parabola. Okay, so when we have our vertex, -4, 1, 2, 3, the vertex is here, and it's a sad parabola. Okay, so the fact that it's a sad parabola, so let me just see here. So 16, -2 plus, yeah, so maybe it looks something like this. The calculator will make it more precise. But that means the focus is going to be somewhere here, and the directrix is going to be somewhere above. Okay, but notice the vertex goes up to y equals 3. So the focus has to be here, somewhere under the vertex, and the directrix has to be above. But if the directrix is above, that means it has to be higher than 3. And the only answer choice that's higher than 3 is 5. So that's kind of like a little hack to the question. But yeah, that's one way to get there. All right. The other way of doing this. So what is the other way? Well, one thing we could also do is find the value P, and P represents the distance from the directrix to the focus. Okay. I'm sorry. The P value represents the distance between the vertex. So here's the vertex, directrix, and focus. So I'm just looking at the formula sheet here. Oh, hang on. So like, let me start a fresh page on this so you can see what I mean. Let me just see. New page. Can I start a new page? Oh, add a page. Here we go. All right. So the formula sheet that I posted, if we use this formula sheet, okay, so I'm just going to borrow this. All right. So here, notice that we still have to get it in that vertex form. So here I have y minus 3 equals negative 1/8. Let me just close this out. Okay, times x plus 4 squared. Okay, so then y equals negative 1/8. And we have x plus 4 squared plus 3. So here, you see how it's like 1 over 4p? So here, what I would say is 1 over 4p. I'm just going to set that equal to 1 over 8. And then that tells you the p-value here is equal to 2. So if the vertex we were saying is at negative 4, 3, 1, 2, 3, then the p-value tells you like how far to go up from the vertex and how far to go down to get to the focus and the directrix. So since it's a parabola like this, once again, the focus is under. So if I go 2 units down, that puts the focus here. If I'm going down 2 from 3, that puts me at 1. If I go up 2 from 3, that puts me at 5. So yeah, if you just memorize the formulas, sure, that'll get you there. But I just like the concept of what a parabola is. Okay, that the focus is like inside the parabola and the directrix is like, yeah, away from it. So I just kind of draw it out each time. That, yeah, helps me out. But that page of formulas is like, fairly helpful, but it could be confusing. So that's why I'd rather just know the concept than memorize formulas. All right, let me just check on the chat. Did I scare everyone away? Oh, more people. Oh, the reference sheet link isn't working. All right, then just hang on a sec. Just Google something for me. I want you to Google Algebra 2 facts. Whoops, to know hold. That one. Alrighty. So let's see. 17, we have this. Blah, 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 blah. So here, I'm going to stop like reading the questions as much. They just want us, G of t is the average price. And t is the number of months since January 1st. The absolute maximum G of t reaches over the domain. So from 0 to 10, what's the max? Okay. So this is like one of those like silly word problems. It's like one of those anti-word problems. All right, negative 0.0049 t to the fourth plus 0.0923 to the third. Okay, minus 0.56 squared and plus 3.23. From 0 to 10. So I'm going to go 0 and 10. Okay. And now for the y maximum, let me go to 20, see what happens. Oh, I could actually, let me clear out that other stuff. So we could actually see here. So what is the max? Well, for this one, I guess what I could do is I'm going to shrink this a bit. Don't need to go up to 20. If the highest number is 7, then yeah. Oh, I'm sorry. Wait, let me just see. If G of t is the blah, 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 the number of months since January 1st, the absolute reaches. All right, let me just. Okay, so the absolute max maybe looks like it's about here. So let me just see. Second, trace 4 for the maximum. I almost want to say like, oh, let's cheat and use calculus, but we can't. Okay, so we can't do that. So for this one, all right, I'm going to rewind back a bit. G of t is the average price of gas in dollars, and t is the number of months. So units, anytime I'm like, what's going on? G of t is the price in dollars, and t is the months, like, yeah, number of months since January 1st. So since all the answer choices are in dollars, we're looking for the Y value. Like this tells me like, oh yeah, look for the Y value. Okay? Like don't confuse it with the X. Just want to point that out. All right, so here I press enter before the top of the hill. And I scroll to the right. Press enter twice and a second time. So here it is. So notice we get this is our maximum. Okay. So people might go, oh, $1.60. But remember the t-axis. Whoops. I'm pressing here. Okay, so the t-axis is in months. So this represents t, and the units would be months. So this one is like evil, definitely evil. The y value is what we want, and that rounds to 4.01. Right? So yeah. Cool. All right, moving on. Written in simplest form, where c is not equal to d, this is equivalent to. All right, so this one you might start by going c plus d times c minus d. This is the difference of two squares. But now the bottom, we want to think about, I just imagine this is like, I don't know, let's say x squared plus 3x. How about like minus 4? Something easier. I'm like, oh, what two numbers have a sum of this and a product of this? And we might go, oh, x plus 4 times x minus 1. So this is like the easy version. Okay, this one is more challenging above it because it's all letters. So this is pretty abstract. So what two numbers have a sum of c? So you see how it's the coefficient? Like if it's d squared, that's almost like our x. So we need a sum equal to c and a product to be equal to this. Now, the giveaway here is I would say, oh, maybe it's got to be like d. So let's see. Maybe it's, if we think about it, maybe it's 2 times c and minus c. Because if I do 2c minus 1c, that's going to give me 1c. And when I multiply those two, all right, there it is. So I have d plus 2c, and I have d minus c. And we can even check. D times d is d squared. D times minus c is minus cd, plus 2cd would give me this, and then minus 2c squared. And now I just got to look. D, oh, all right, so this one's another funny one. So this and this cancel, but they make negative 1. All right, the reason being, so this, if you just know they cancel and make negative 1, then great. But just know when you have something like a over b divided by this, it's negative 1. As long as a is not equal to b. Okay, so if you know that, then this just cancels. Okay, and makes a negative 1. And if I put the negative 1 on top, now I do negative 1 times c is negative c. Negative 1 times d is negative d over d plus 2c. Okay, so that's choice 3. Hard question. Or you can just pick out random letters for, I'm sorry, pick out random numbers for, C and D. But like, don't pick one for both. Well, C can't equal D. If you pick like C equals 2 and D equals like 5, it'll probably not give you more than one correct answer. All right, so this one, what is the remainder of this? Or this one, maybe I'll use synthetic. So this one, just think P of X here is equal to 2x to the third. I'm going to put plus 0x squared minus 3x plus 5. So when I do the polynomial, I'm sorry, synthetic division, I have 2x to the third, 0x squared minus 3x plus 5. And now I need the root. Like, what is the root of this? It would be x equals 5. This goes on the outside. And then we start the process. 2 comes down. 5 times 2 is 10. 0 plus 10 is 10. 5 times 10 is 50. 50 minus 3 is 47. 47 times 5 is 235. And 235 plus 5 is 240. There's the remainder. Okay, so synthetic works really nicely. If we write the leftovers up here, this tells us 2x squared plus 10x plus 47. And the remainder, 240, would be over x minus 5. Okay, so that's what the remainder means. All right. Cool. So moving on. Question 20. Oh, simulations. All right. Let's see. So we've got the results of simulating tossing a coin 10 times. Wait. The results of simulating tossing a coin 10 times. Okay. Recording the number of heads and repeating this 50 times are shown in the graph below. Okay, so someone tossed a coin. So it's a simulation about tossing a coin 10 times. And it was repeated 50 times. Based on the results of the simulation. So it's based off of the result of the simulation. Which statement is false? Okay, 5 heads occurred most often. That's true, which is consistent with the theoretical probability of obtaining heads. Yes, there is a 50% chance when you flip a coin that you'll get heads. Like, sure, this one is true, so 1 is like not likely the answer, but if we need to double back to it, then we will. 8 heads is unusual as it falls outside the middle 95%. Okay, so we can say something is unusual if it goes outside the middle 95%. Like this is true, this is true, this is true. But the thing we have to verify, so this we have to investigate. Is this falling outside? Well, this was repeated 50 times. There's 50 dots here. So if we look, 8 is over here, and there's 4 of these. Okay, so you see 8 heads is unusual as it falls outside the middle 95% of the data. Well, if we see here the average is 5, do they tell us standard deviation? Well, let's just see. 7 heads is not unusual as it falls within. So I would say here, like this is going plus 3. So if I go minus 3, that puts me here at this. Okay. Okay, so notice from here to here is like plus 3. Here to here is minus 3. So 5 plus 3 brings me to 8. However, if we look, see how like the plus 3 minus 3 puts me here? So the blue stuff, that's 1, 2, 3. There's 3 out of the 50 is 6 out of 100. That's 6%. So that means everything here, so far that's like 94-ish%. But you see how this is within 94%. So right away, this one's false. 8 heads is unusual. It is not because it falls within that interval. Okay, it's from 2 to 8, the middle 95%. Like, see how like this is even 94%. So it's like, yeah, just there. So that's the one that's not looking good. Obtaining 3 heads or fewer occurred 28% of the time. Well, let's just see now. We're going to count this. If we count this, I want to see if the other answers are out of whack. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 out of the 50, which is equal to 28 out of 100 or 28%. So obtaining 3 heads or fewer occurred. Yep, that one is true. 7 heads is not unusual. It is not because it's within the middle 95. So that's also true. So 2 is the culprit. Okay, what is the inverse? So what you do is, I just imagine this says y equals, because remember, y equals f of x. So what we're going to do is we're going to switch x and y. So I'm going to say, instead of y equals this, I'm going to say x equals -6, y minus 2. And then what we do is we solve for y. So from here, I could distribute. All right, I could also divide by, this is 1. Yeah, you know what? I'll show that way. Firstly, I would divide by -6 first. And now you have negative x over 6. Oh, just no, x over -6 is equal to negative x over 6. And this is equal to minus x over 6. You could write it three ways. Equals y minus 2. And then just go plus 2. So now this cancels and I get y equals, I can write my 2 first, plus 2 minus x over 6. That is my inverse. Okay. 21 is 2. Yes, be in radians when you're graphing sine and cosine curves. And don't cheat. Not worth it. Just take the L, as you would all say. All right. So question 22. Now we're doing, so you get formulas for the test. So if I zoom to the end, we'll get there. This is the formula I'm going to use. Okay, geometric series, this formula. So I'm going to borrow this. Okay, and I'll go back to the test. Oh, wow, hour 20 already. Maybe I got to pick up the pace a little. I think I showed like too many methods for the first few questions. I'll make this more like crash coursey. Yeah, only because I would want people to like get a good night's sleep too. I don't want to stay up too late doing this. All right. So for this one, Brian deposited 1 cent on, he deposited 1 cent into an empty non-interest bearing bank account on the first day of the month. He then additionally deposits 3 cents on the second day, 9 cents on the third day, and 27 cents on the fourth day. What would be the total amount of money in the account at the end of the 20th day? All right. So here, he is depositing this. So he's just adding this money continuously. So here, remember, this is cents. So basically, like on the second day, he would have like A1 plus A2. So this is, for one, this is a geometric sequence. Because you see the pattern here is we're multiplying by 3 each time. 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27. So this is a geometric sequence. But the question is asking something different. They're asking us, what would be the total amount of money in the account if this pattern continued? So he's depositing it into the account, so it's adding up. So on the 20th day, how much would there be in total? There would be A1 is 1, minus A1 is still 1, R is 3, so the N is 20, over 1 minus R. And then just calculator, okay? So calculator, I'm going to press alpha y equals enter. We have 1 minus 3 to the 20 divided by 1 minus 3. But this is the number of cents. To find how much money in dollars, notice the decimals, then I divide by 100 to convert cents to dollars. And it's 1,743,3922. So that is 17 million. So it looks like choice 2 here. Okay, so choice 2. All right, if the function g of x equals a times b to the x, and it represents exponential growth. So exponential growth means it should look like this, not exponential decay. Which statement about g of x is false? So we want the one that's false. So here, a is greater than 0 and b is greater than 1 would definitely be exponential growth. Just pick out random numbers and it'll look like this. So 23 is not 1. The y-intercept is 0a. That one also is true because if I plugged in x equals 0, I would get a times b to the 0, and that would give me a times b to the 0 is 1. That would get a, which matches this. So this one's out. Okay, the asymptote is y equals 0. That is true. That is true because if we look here, the asymptote, horizontal asymptote, is the x-axis. But the fancy name for the x-axis, this is the line y equals 0. Okay, that's the horizontal line here. So it has to be this. And the reason why this is false is that an exponential function like this, that isn't like they're not doing plus or minus anything. Notice there's not like a -5 or nothing. Just a b to the x never touches the x-axis. So this thing has no roots. If it has no roots, that means the y value, like this, is not possible. Can't have y equals 0. Not possible. Okay, cool. Alrighty. So what do we have? At her job, Pat earns $25,000 in the first year and receives a raise of $1,000 each year. So $25,000, $1,000 raise. Now she has 26, 27, and so on. The explicit formula for the nth term. So they wrote us an explicit formula. Which rule best represents the equivalent recursive formula? So recursive is defined by the terms before it, and you need to define the first term. So this one is out because these are explicit. So these are the only recursive ones because they give you a first. They have the same first term, but now this one would be it because the recursive formula is built by the terms before it. So this is saying like this is the previous year. If we take the previous year and we add 1,000, that's going to give the new amount. And you can even see here, like this is the first year. This is A1. This would be A2 and A3. So let's say I wanted to plug in n equals 2. See how that would give me A2 equals A sub 2 minus 1 plus 1,000. And this would give me A2 is A1 plus 1,000. And A1 is 25,000 plus 1,000. Give me 26,000. Okay, so that's why it's choice 3. All right, cool. Oh wow, more than 3,000 people stopped by. Thank you so much for the support. And if people haven't done so yet, I'll just say it once as we move on to the next section. If this has been helping, please like and subscribe if you haven't done so. And if you plan on taking AP Calculus, I live stream for AP Calculus also. And I just started adding grades 3 through 8. I'm doing the New York State exams for grades 3 through 8. So if you have, younger siblings and you're like, oh, hey, he does those grades too. I don't have as many as I do for high school, but I'm going to build it up over the summer. All right, now I move on to water. Okay, so this one. So Elizabeth, so part 2's worth 2 credits. Elizabeth tried to find the product of these two binomials. Here's her work. Identify the error and determine the correct product. All right, let's see. Where did Elizabeth mess up? 2 times 3 is 6. 2 times minus I is minus 2i. 4i times 3 is 12i. 4i times minus I is... So far, so good. And then Elizabeth combined like terms. So see, here to here is good. However, I squared is -1, not +1. So here to here, there's the error. Okay, I squared is -1. Okay, so Elizabeth plugged in. Oh, let me make sure I'm following the chat too. So, yeah. Let me just see. Okay. Blah blah blah. All right. Well, seems like it's just healthy stream. All right. So Elizabeth plugged in. I squared equals 1 instead of I squared equals -1. Okay. And determine the correct product. So here, I mean, we could just like copy up to her correct stuff. Like, might as well use part of her work since we're checking it. So we say, all right, so this was, let's see, 6 plus 10i minus 4i squared. But now I could say this is 6 plus 10i minus 4 times -1. So this is 6 plus 10i plus 4. And now combine like terms, 10 plus 10i. There it is. 2 points. 1 point for saying her mistake, and 1 point for fixing it. Oh, one of these questions. These are nice. All right. Exponential regression. These have the potential to be very easy if you just know how to type it in. So stats, edit. A is going to be X. D is going to be like Y. So we'll put L1 is A. L2 is D. So now we just type 4/9, 5/9, 6/9, 8/9, 1, and then 2, 2, 2.25, 3, 3.25. Okay. Now I go to math. I'm sorry. Now I go to stats, calculate. Exponential regression is option 0. Enter, enter all the way until we calculate. And then here's all the stuff we need. All right, this one, we honestly just have to write it out. However, please don't make the mistake of using the wrong letters. I know they're using Y and X, but yeah, we have to use A is corresponding to the X here. So yeah, just know like this is corresponding to, let me get out of this. This is like our capital A. All right, and we have this is capital D. So it's kind of annoying because they didn't use X and Y, but I mean, whatever. So we're going to say D equals the coefficient. I'm sorry, yeah, the coefficient, not the base. The coefficient is 1.223. We're rounding to the nearest thousand. Okay, and then B is 2.652. And we're calling this, instead of X, we're calling it capital A. All right. Cool. All right, so that is that question. Yeah, these, like, if you know the buttons, it's such an easy 2 points. Just like try not to make a typo is really it. All right, so this one's nice. A formula for work problems involving 2 people is shown below. The time, so T1 is the time it takes one person to complete a job. T2 is the time it takes the second person to complete the job. T sub B is the time it takes for them working together to complete the job. So Fred and Barney are Flintstones, aren't they? Did they go Flintstones here? That was cool. I guess they have a sense of humor. Does anyone watch the Flintstones? Anyone watch the Flintstones? Oh, I'm a dinosaur now, right? They really sneak that by? That was, yeah, that's because millennials are making the test now, so that's like a millennial thing. All right. So let's just see. Fred and Barney. So Fred takes 8 hours. So that's 1/8. Plus, because T1 is the time it takes the first, we'll say Fred. And we'll say Barney is the second person. And Barney takes 6 hours. Write an equation that could be used to find the time it would take both carpenters working together. That's T sub B. So there it is. And now solve. Did they say algebraically? They didn't say algebraically. So technically I could solve this with a calculator. I could just say I did second trace 5. Yeah, I mean, if you want to just do this in the calculator, you can. They didn't say algebraically. So technically, you don't have to do the algebra. Okay, so just know this is an option. I already showed how to do this earlier, so I'll skip that part. Okay, so this. All right, so algebraically, let's say I want to do some algebra. Then I need common denominators. I'll do times 3/3, and I'll do times 4/4. So 3/24 plus 4/24 equals 1/d sub b. And now 3/24 plus 4/24 makes this. Okay, now here's the nice little algebraic thing. One fraction equals another fraction, you could flip both sides. So I could say t sub b is just 24/7. You could cross multiply and divide, but it's going to, kind of be a waste of time here. 24 over 7 to the nearest 10th. So to the nearest 10th, you could just type it in. It's going to work out to 3.4. Okay, so I'll just say, whoops, I don't know what buttons I'm pressing. So this, and I'll just say 3.4. Cool. All right, this one, what was annoying about this one? I think this is the question that, like, yeah. So this one, I'll say roadblock. People probably went like, okay, x times x plus 3y plus 1 times, and they're like, oh no. Like, oh no. What happened? So here, like, try something else. Math is filled with moments like this. Like, you got to just try something, like move something around. And I'm like, all right, well, what if I rewrote this as x squared plus y? So I just switch, these terms around a bit. And then I have 3x to the third plus 3xy. Now let's see what happens. So this is still like, all right, 1 times x squared plus y. So maybe not looking good. But now I take out a 3x from these two. And I've got x squared plus y, and there's the match. Okay, so now I take out x squared plus y, and I've got 1 plus 3x. And there it is. Okay, this is what we need. All right. Don't actually write, oh no. Like, hopefully you would erase. So, like, say, nope, not you. All right, researchers in a local area found that the population of rabbits with an initial population of 20 grew continuously. Oh, wow, so this one again. So twice with this formula. All right, so let's see. So rabbits and, whoops. So rabbits and foxes. Oh, how are you allowed to rearrange? So at Liam, it's commutativity of addition. Okay, in addition, like if I say like 7 plus 5 plus 3 plus 2, like just know like that would make 12 plus 3 plus 2, and that would make 15 plus 2 is 17. If I were to just switch and go like, oh, 7 plus 2 plus 3 plus 5, I just start swapping these, and I just go left to right, I get like 9 plus 3 plus 5. I'm still going to get 17. Okay, so the order that you add doesn't matter. You're allowed to switch things around a bit. All right. Okay, so, all right, rabbits, foxes. So population of rabbits with an initial population of 20 grew continuously at this rate. So their amount is 20 e to the rate is 5%, but 5% is 5 out of 100 is 0.05. Okay, and then foxes, initial population of 30, e to the rate is 3%, which is 0.03 t. So here, find to the nearest tenth of a month how long it takes for the populations to be equal algebraically. Okay? So, yeah. Oh, hang on a sec. I'm going to mute some of the silliness here. All right. Wait. That's one. Okay. All right. So, moving on. So, I'm going to set these equal 20 e to the 0.05t equals 30 e to the 0.03t. And I'm just going to say that from here, I'm doing second trace intersection. You know, it doesn't hurt to just describe what you did. And then here, watch, I'll show you the calculator. Because they didn't say algebraically. So there's like, if they say you could do it any way you want, like you have these amazing calculators, just, you know, use the calculator. You can do it algebraically, but it's like unnecessary extra work. So 30e to the... Okay. So now I press graph, and I'm like, oh no, I can't see anything. I press zoom 6. Oh no, I still can't see anything. And the reason is, if I look up, 20, 30, when are they equal? This one's under, this one's over. And when does it switch? And it's going to switch like from 0 to 25, let's say. So 0 to 25. And let's say I go up to 70 because I was in the 60s. And there it is. So I want to point that out again. I saw where they reversed, like where this one was under and now it's over. I had to go to about like up to like 23-ish, so I went out to 25. And I saw 63, so like let me go a little higher. And that makes the picture nice. That's just a nice little trick. Now I go near, second trace 5, enter 3 times. Okay, and then this gives me what I need. And it's 20.3. All right, that's it. That's all you got to do. All right, consider the function h of x and the function q represented in the table below. Determine which function has the smaller minimum value. All right, well, this is something we're going to have to know or deal with later in the last question, graphing a trig function. So this is the midline, and this is the amplitude. Okay, so that's the amplitude. So what I'm imagining, or I could even draw it out, is I just imagine like the y-axis. I don't really need to trace the curve itself. But I know if the midline is at 1 and the amplitude is 2, it's going to go 1 plus 2 is 3, and 1 minus 2 is -1. So the minimum value here of h of x, so the min value, I'll write it over here. So the min value of h of x is equal to -1. Okay, so that's the minimum value of h of x is -1. And the min value of q of x equals, from the table, and we're on the domain from -2 to 2. The min value there is -8. Okay, so which one has a smaller minimum value? It's going to be q of x. Okay, justify means like show work. So q of x has the smaller minimum value. That means like don't just guess. I mean, I can say, how about just sprinkling, because -8 is less than -1. Okay. If you have to, you could just graph this, and then you could, trace the minimum as well. That's also fine. Like if I did, so let's see, 2 sine 3x plus 1. Right, that was it. And I go from -2 to 2. And I'm going to go back to -10 to 10. See, the minimum, I could press second trace minimum. And I could pick any one of the minimums. The minimums are the same because the curve repeats itself. I hit enter before, enter after, enter a third time. And wait, what did I type in here? Let me just see. 2 sine 3x plus 1. What actually happened? Let me try that again. Second trace. Oh, wait, I think it worked out nice. I just wasn't thinking right for a second. Yeah, y equals -1. Yeah, it was fine. Cool. All right, sketch a graph of h of x. Oh. Cool. Yeah, just spamming. So there are no leaks. So yeah, it's just gonna yeah, keep the, because I want the chat to be, you know what? Let me do this too. Although this chat I really didn't have to do it for, but slow mode. Yeah, I usually put on slow. I started putting on slow mode so people could only comment every 20 seconds, so they can't just spam away. All right, so this one, give it and put XY axis, but just sketch. All right, so here, so, all right. So the zeros of a quartic polynomial h are -1. So here's -1, +2, -2, and 3. All right, now this is the same concept from algebra. Roots and factors have an opposite relationship. Okay, so h of x equals, if I have a root at -1, my factor is x plus 1. If I have a root at -2, that's a factor of, I'm sorry, a root at -2 would be a factor of x plus 2. But since I have plus or minus, I have both of those factors. A root at +3 is a factor of x minus 3. And then I could just use the calculator to get a sketch. And remember, you're only sketching this. All right, so it doesn't have to be like the most amazing graph. You don't have to like sit there and like plot a million points. Okay, sketch means you just have to get the shape right. But I don't know, like if you want to like add a little more detail to it, it's just going to take more time. But if it gives you peace of mind, I'll zoom 6. And let's see, window. I say I go up to 50. All right, that's better. So here, let's just see. If I go to the table, yeah, see, these numbers are like kind of insane. So 0 and 1 gives me 12. And then everything else flies away. Yeah, that's like kind of a lot. So yeah, this one, I mean, I guess I could scale it by 6s. I want to count by 6s, like that'll work. I don't, yeah, really, I guess have to do that, but let's just see. So if I count by 6s, so then 12 would be here. So 12, 12, and at 4, I'm counting by 6s, so that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, see, I already have to like, let me just, I probably should have drew this more central. Yeah, so try to center your graph for one. I'm gonna try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But if I'm counting by 6s, then that would be 60. All right, and then at -3. Okay. So, I mean, it takes an extra second, but they don't require you to do this because you're only sketching. But it just gives me peace of mind. Like, this doesn't take that much more effort. All right, and now I just remember the picture. I'm like, wait, what did this look like again? That was so long ago. Oh, so it's kind of like a W, but like a loopy W here. All right, so now for the fun part. Actually, maybe putting the scale makes it more risky because then I have to really be precise with the minimums. So maybe these I was just better off going like this. Okay, so here I'll just go down, up, and then down, up. But I want to make sure of one detail. The maximum, second trace 4. If I hit enter before and after, it's very symmetric here. Yeah, it's at 1/2. Yeah, so at about 1/2, that's fine. That would get full credit. Okay, so this is our sketch of h of x. Cool. Not the best artwork, but they'd be like, sure. Ugh, explain why this. I mean, power over root. So the fourth root of 81 to the power 3. The fourth root of 81 is 3, and 3 to the third equals 27. So I just write that in words. So, okay. So I'll just say this. 81 to the 3/4 is the fourth root of 81 raised to the third power. So am I just saying everything? I kind of don't like these questions. All right. Let's just see. So I guess I'll just say the steps then. All right. So the fourth root of 81 is 3, and 3 to the fourth. I'm sorry, and 3 to the third. It's 27. That's annoying because, I mean, this just shows you know how to do it. But whatever. Is the fourth root of 81 raised to the third power? The fourth root of 81 is 3, and 3 to the third power is 27. Cool. All right. Part 3. We made it. So 4 points for these. All right, and we're making good time. I guess I kind of flew through this part of the test. So here, just express this as a polynomial in standard form. So f of x times g of x. So I'm doing f of x times g of x minus, and then we have f of x plus g of x. All right, so piece by piece. That's 2x to the third. 3 hours for the test. Yeah, the test is 3 hours. Okay, then I distribute the x. I get x times x is x squared. X times minus 1 is minus x. And then we distribute the minus 3. Minus 3x. And we get plus 3. And then we have minus. And the stuff here I'll write in this color. So we have 2x squared. I have x plus x is 2x. And then I have negative 3 minus 1 is minus 4. Okay. So now for the next part, we have 2x to the third. It's the only x to the third term. I have a minus 2x squared plus x squared is minus x squared. And then I've got minus x minus 3x is minus 4x plus 3. And now this part, distribute the minus, you get minus 2x squared minus 2x plus 4. And now for the final answer. So we've got 2x to the third minus x squared minus 2x squared is minus 3x squared minus 4x minus 2x. You're doing minus 4 minus 2 is minus 6. Back on the x. And then 3 plus 4 is 7. So there is the expression in standard form. Oh, that's a good question, Adidas. Why are you learning this? I don't know. If you want to inspire some change, like I would say, like, yeah, I'm all for people getting active. But right now, that's just the way it is. But I guess they want you to be well-rounded. I mean, when are you gonna ever have to do one of these polynomials? Like, probably not. But it just shows that you know how to like follow a process and you know how to think. You have, analytical skills. Math is like really all about logic and reasoning. So that's what you're proving to people. They're like, hey, I could think logically. What's the curve looking like for this year? I would look at the most recent one to answer that question. So if I go to the New York Regents website and I pull up Algebra 2 and I go as recent as January, conversion chart. Well, yep, that'll do it. So 13 multiple choice in January. Ready? Here. So let me. So that was January. Okay, so the 65 was a 26. 13 multiple choice. Oh, I don't know. They made it easier to pass. I mean, I'm not going to say it's an easy test, but they lowered the mark. So a student is chosen at random from the student body at a given high school. And the probability that the student selects math as their favorite subject, I'm going to say probability that they love math, is 1/4. Probability that the student chosen is a junior. So probability of getting a junior, probably almost 1/4, maybe not exactly. All right, if the probability that the student selected is a junior or that the student chooses math as the favorite subject is this, what is the exact probability that the student selected is a junior whose favorite subject is math? Okay, so here's the concept. I like to use Venn diagrams. So like there's math and juniors. So there's people who like math, people who are juniors, and people that like math that are juniors. So if we're looking here, they told us the probability that someone likes math or is a junior. This means like union like means or. They're telling us the probability that the student selected as a junior or they like math is 47 out of 108. Okay. But I want you to think about something. The probability that someone likes math or is a junior is equal to the probability that someone likes math. Okay. So it's like all of these people plus all of these people. However, if you notice this space here, if I add the probability of people that like math and the probability, if I add the number of people that like math and the number of juniors, then what I'm doing is I'm counting that space twice. I'm adding these people twice. So I have to subtract the probability of people liking math and being a junior because this gets counted twice. Okay? So then here, what we do is we just plug in. So this is 47 over 108 equals 1/4 plus 116 over 459 minus this. Okay, and now just go ahead and do the math. If you do this in the calculator, do this plus this, math, enter, enter. Well, this stays like this. I promise these two, when you add them and math, enter, enter it, is going to make 923. It's 923 over 1836. All right, but I trust if you go back earlier in the video, you could see how I add fractions. All right, unless you've been following all along. And now I subtract this to the other side. So let me just shrink this down. So group. Okay, and now I'm going like this. Whoops, 1836. Okay, so this is gone. And that's going to give us negative 31. I promise if you do this minus this, math, enter, enter, you're going to get this. However, we need to find the positive, so we could say the probability of someone liking math and being a junior is 31 over 459. Okay? But that's the concept. The overlap, when you do probability of people liking math plus the probability of people being a junior, you're counting the overlap twice. So that's why you have to subtract out the overlap. All right. And now, are the events the student is a junior and the student's favorite subject is math independent of each other? Okay, well, one nice little formula you could use for this is if this is true, if the probability that someone likes math and is a junior is equal to this, this would mean that the events are independent, okay? That they have no effect on each other, okay? If they are not the same, then they do affect one another. Sorry, this was hitting my glasses. I was itchy. All right, so now we just plug in. So 31 over 459. Let's see. Equals, and I'm doing probability of m times 116 over. So then we get here, and let's just see. So this one, if you multiply these two, it works out to 29 over 459. Okay, so now we make an observation. We say this is not true. Okay. So now I'll just comment since, let's see, did that take? Oh, it did. Okay, so since the probability of someone liking math and being a junior is not equal to the probability of someone liking math times the probability of someone being a junior, this means, let's see, the events are not independent of each other. Cool. All right, now we'll check on the chat because I haven't looked at the chat in a bit. Hope everyone's doing okay. All right. Oh, wow, the chat's really rolling here. And we got 500 people on too. Thank you so much. People being here to support. All right, 35 more simulations. This kind here is like pretty standard. Let me just zoom in. Okay. So a random sample of 250 men in the US aged 21 or older, 139 are married. And the graph below simulated samples of 250 men 200 times, assuming that 139 of the men are married. Okay, let's take a look here. Cool. So based on the simulation, create an interval in which the middle 95% of the number of married men may fall. So this just know is plus or minus 2 standard deviations from the mean. So if we have a mean of this, I take 138.905 and I go plus 2 times the standard deviation. Okay, so this is our interval. That's the maximum value here. And then the minimum value, I take the mean and I go minus 2 times the standard deviation. Okay, so you take the standard deviation, you double it, and let me just fix this. Whoops, I don't know what I just pressed. Okay. Yeah, sorry, I've been long day. I'm definitely starting to feel it now, but we're almost there. Okay, so this is just calculator work. Do this number minus 2 times this number, and then round to the nearest integer, whole number. So here we're going to get 123. And if we round to the nearest whole number here, get 155. Okay, so that's for this. So 123 to 155 gets us 2 points. Now here we go. A study claims 50% of men 21 and older in the US are married. Do your results from part A contradict this claim? Contradict means like prove it wrong. Well, if we look 50%, so here I would find the sample was of 250 men. So if I take 50% of 250 is 125, just divided by 2. And notice 125 falls in the middle 95%. So that means 125 is not unusual. So a study claims that 50% of men 21 and older in the US are married. Does this contradict the claim? No. Okay. This does not contradict the claim because 125 falls in the middle 95%. Okay. So we could say here, since there's a few different ways you could explain it, but you could say 123 is less than 125 is less than 155. So 125 falls in the middle 95%. And I could say, therefore, the results, what happened here? Oh, just know the 3 dots I just wrote, then had to erase, means therefore. This means therefore, I promise. So therefore, the results part A do not contradict this claim. Okay, and that should have been an S. Let me just fix that. So the results in part A do not contradict this claim. Cool. Alrighty. Moving on. 36. Write an equation for f of x and then a translated one. And then this is the second to last question. Okay. This one, there's a nice trap in this question, but you have a calculator to check yourself. So here you have a root at -1, 2, 3, 4. So at -4, at 0, and at 3. So I always call it the bear trap. Okay. Oh, good luck at Josh. Good luck. Good luck to everybody here. I hope you all, do okay. But the trap. Okay, so here's the trap. Is people might just go, oh, the roots and factors are opposite. So x plus 4 gives me that root. X plus or minus 0, I could just say x. And then they say x minus 3. The problem, though, right? The bear sound is here. Okay, this has even multiplicity because it does not go through the x-axis. It approaches the x-axis, it's tangent to the x-axis, then it goes down. So this, I could put a square here, okay? And I'll show you, once again, why that works. So if I write x plus 4 times just x, and then I write my x minus 3, and then zoom 6, See, this does not look like this. Okay, however, if we make that an x squared, let me see, what's the, there's someone was saying second delete, is it? Oh yeah, second delete inserts, so you don't have to like delete everything in sight. That works. Okay, so I think zoom 0. Actually, that was kind of terrible. Let me go -20 to like 50. Or maybe 100. Let's see where that goes. Yeah, it's a little better. Let me go lower. How about -50? Yeah, it's better. See, that looks good. If we make it a square, not x. Okay, so we need that square. All right? So that'll dodge the trap. That's why use the calculator to check your answer before you call it the finished product. And it probably looks better if you say like f of x equals, like I would write the x squared first. It looks silly the other way. Okay, and now this last part, let me just move this over. The function g is formed by translating f left 2 units. So here, what we could do is we go left 2 units. That's our new root at -6. Left 2 units is our new root, but remember, this has even multiplicity. Okay, and then left 2 units puts us here at 1. Okay, so when we write the function for g of x, right, g of x has a root at -6, so there's going to be an x plus 6 there. Let me just write that lined up. So x plus 6. And then the one here at -2, I'm going to write x plus 2, but it's even multiplicity, so I'm going to square this. And then the next root is at 1 of x minus 1. Okay? And that should be good. All right, x plus 6, x plus 2 squared, x minus 1. So I would just translate the roots and then write it from there. If you want to go piece by piece and replace these x's with x plus 2's, you can do that, but the algebra gets a little tricky. So this is probably easier. Final question. We made it to the end. All right. So part 4, 6 credits. So this one, it really helps if you know the formulas like for midline, frequency, period, and amplitude. Even multiplicity, so at Anas Ahmed, is when I have a factor, let's say something like x plus 5. So zoom 6. See how like I have a root, but it goes through. If I make this x plus 5 to the third, see how it still goes through because the power is odd. But the moment I make the power even, now it no longer goes through the x-axis, it's tangent to the x-axis. Okay, so it just tells you like when the factor has a square or an even power, it doesn't go through. Okay. All right. So here, the resting blood pressure of an adult patient can be modeled by the function P of t, where P of t is measured, P of t is the pressure in millimeters of mercury after time t in seconds. Okay, so a little medicine for you. And now this is kind of weird. Notice that it's like ripped. So what's really going on here is we're starting at 90 and then we create our own scale. So this one, I take time to make the scale because I want the graph to look as nice as possible. This is our midline. We have a midline here. We have an amplitude of this, and then this is our frequency. Okay, the coefficient there is our frequency. Now, one thing to point out is that the period is 2 pi divided by the frequency, which is the coefficient of the variable. And this is going to tell us the time to complete, to complete one cycle. Okay, which is actually one of the follow-up questions. So the period is how long it takes to complete one cycle. So let's say this is 0 over here. I'm gonna say like, all right, this is 0. Then 1, 2, 3, 4, 5, 6. We're counting by sixth. So this would be a third. And this would be 2/3. So when we draw one of these waves, it's going to complete a full wave here from 0 to 2/3. Okay. And then if you look, it's like, another third. So another full cycle from here. And then it's going to have 3 full cycles here. Okay. So 1, 2, 3, 4, 5, 6. We'll say this is 2. And that makes sense because our domain is going from 0 to 2. All right. Now, one thing that I'm thinking of ahead of time is I do the midline. So the midline is 120. And I go plus or minus the amplitude. And that's going to send me to 96 and 144. So I want to go from 90 to eventually 144. So this is where things get, I guess a little bit interesting here. Like if I want to get to 144, well, I got to think about what could I count by. So this is like some math I'll do on the side because I want my graph to look nice. I don't want to have to like plot in the middle of a square. So I want to go from, so 48s, like I have to cover 48. Okay, I have to cover twice the amplitude. I'm starting at 90. I want to get to 96. So I could try counting by sixes. And let's see what that does. Like this is 96. And then this would be 102, 108. Okay, 108 plus 6 is 114. And then 120, the midline would be here. See that? So I have 96. Then I have 102, 108, 114, 120. And this would be 126, 126, 132, 138, 144. See that? There's 144. Just make that a little neater. So 144. And these are the values we want. This is the min, and this is the max. Okay, so when you think about, at least when I think about a sine curve or a cosine curve, like you have the midline, and the distance from the midline to here or here is equal. Okay, it's both equal to a. Okay, so it's like a going this way, a going this way. All right, that's why I'm doing this. So midline, max, min. It is a cosine curve. So a cosine curve, I just think, oh, cosine starts here and goes like this. All right, you do get a calculator, but I like to do these without a calculator. I think it's a fun exercise. And the way a cosine curve works is it goes max, midline, the minimum, back to the midline, and then it goes back to the max. This is like one cycle. So it goes max, midline, min, midline, max. Right? So that's 1, 2, 3, 4. So I'm going like 1, 2, 3, 4 slices here. So here's 1, 2. So this one, let me just see. 1, 2, 3, 4, 5, 6. So I mean, I could just break this up as carefully as possible. Remember, the period is 2/3. So my first cycle is going from 0 to 2/3. So I need 4 sections. Okay, so I'm just thinking out loud here. But 4 sections. So I'm starting here 0, and I'm starting at 144. Okay, and then remember, I go max, midline, min, midline, max. This is one cycle. Okay, and it takes 2/3 of a second to complete one cycle. So I'm going max, midline, minimum, then I go back to the midline, and then I go back to the maximum. And there's one full cycle. And I'll try to make this as neat as possible. Okay, and then 2/3, you see, it's like 2 skips like this. So then the next one would go from here to here. But it's the same pattern. Okay, it's max, and then midline to the minimum, here, and here. Okay, and then for the last one, here I'll color code this. And I'm going to go max, midline, minimum, midline, and max. Okay, there you go. So now calculator. Of course, you get a calculator. So what you could do is you could always just type this in. Make sure you are in radians. All right, I'm not going to tell you to do this no calculator, but if you want to flex, do it without a calculator. Okay, plus 120. Now I press graph and I'm like, oh no, I can't see anything. And that's because we're going from like 90 to 1. Let me go from like 90 to 150. So 90 to 150. And the x is going from 0 to 2. And there it is. Okay, and if I make my table, I'm going to press second window and I'm going to go to ask. I could just type in custom values. Like we have 0, and then I'm counting by 1 over 6. So I have 0, 1 over 6, 2 over 6, 3 over 6. Let's say I don't know 3 over 6 is a half. I could just keep doing this. 4 over 6, 5 over 6, 6 over 6 is 1. Then I have 7 over 6, 8 over 6, 9 over 6, 10 over 6. So look, if you really had to, you could just use the calculator to get these values. But it's going to give you, yeah, all the stuff that you... What did I write silly here? Let's see. Oh, no, this seems fine. Is it? Wait, I think I made a typo. Forgive me. 7 over 6. This was 7 over 6. 8 over 6. 9 over 6. Oh, 10 over 6. Okay. Oh, I guess it's cutting me off. Whatever. But you get the idea. You just type in the values and it'll give you these. You plot them and connect and make it look nice. Okay, but it helps to know the theory behind this too. All right, so that's what I like to do for questions like this. Anything else worth mentioning? No, I think considering it's the night before. All right, determine the period. Well, I did that over here. The period is, so the period, remember I did 2 pi divided by 3 pi, which was 2/3. Okay, and what does it represent in the given context? Well, remember, the resting blood pressure of an adult patient can be modeled by the function P. So really what it's telling you, 2/3 is how much time it takes someone's blood pressure to complete one full cycle. So it takes 2/3 of a second, which I honestly just learned like from doing this Regents is, yeah, like you know how you get like two numbers for your blood pressure? So like the high number is like, yeah, the high, and then the low number is the low, but it's like your blood pressure is cycling between those two numbers. So pretty interesting stuff. But I'm going to stay in my lane. I don't really know much about medicine. Okay, but I would say here, it takes 2/3 of a second for the adult patients. I'll abbreviate blood pressure with BP to complete one full cycle. Cool. All right. So normal resting blood pressure for an adult is 120 over 80. This means that the blood pressure oscillates between a maximum, so this is important, of 120 and a minimum of 80. Adults with blood pressure above 140 over 90 and so adults with high blood pressure above 140 over 90 and adults with low blood pressure below 90 over 60 may be at risk for health disorders. Classify the given patient's blood pressure as low, normal, or high and explain your reasoning. Okay, well, for that, the max is 144, the min is 96. So let's just see. So the patient, let's see, they have a max of 144 and a minimum of 96. So let me just double check that. Yeah, 144 and 96. So think about it. They have high blood pressure because their max 144 is greater than 140 and their minimum 96 is greater than 90. So then we just have to explain our reasoning. So classify, I'll say high. The patient, whoops. All right, let's fix this. So the patient has high blood pressure. Okay, and how do we know? It's high blood pressure because their max is 144. And I'll just comment here, which is greater than 140. And their minimum is 96, which is greater than 90. That is it. Okay. Last thing I have to write. Cool. All right. Alrighty, let's just see. Oh wait. Yeah, say nice things or you get hidden. Okay. All right, well, let me see what time. Oh, 10:20, reasonable time. I would say algebra 2 is it depends on what you're better at. Some people think geometry is like insanely hard and some people think it's much easier. But I don't know. I would say just do your best. Go to class. To everybody, I know phones are so nice. Their technology is as great as it's ever been, right? I mean, it's 2024. But when you're in class, I personally try to encourage my students to keep your phones away. I keep mine away and just try to, in your language, lock in for the time that you're in class. Focus. You do your homework. If you don't know how to do something, ask questions. You'd be surprised how far that gets you. So, yeah, that's my advice on that one. So, all right. Well, let me see anything. Oh, I'm happy to help. As Sebastian Reyes, yeah. Um, good luck to everybody. So that'll be my final words here. Is just good luck. Thank you for being a part of this. And yeah, we broke 5,000 views for Algebra 2. Like that's really awesome. The numbers are just like going up and up, and I'm just happy that I'm able to reach that many people and help, that many of you. But I'm proud of you all for sticking it out. And yeah, so good luck. Let me know how you do. You can just pop on one of my random videos and leave a comment like, "Oh, it was easy," or "Oh, it was difficult. I got cooked," or "I cooked." Whatever wound up happening. But either way, last thing I'll say is, get a good night's sleep, or do your best to get a good night's sleep, and then just show up tomorrow and do your best. Okay, that's it. That's really all you have control over. It's normal to be nervous, but try to convert that anxious, nervous energy into test taking energy and just do your best. Right at this point, whatever happens is going to happen. You're not going to learn the entire course overnight, so just try to get some rest. Okay? So take care everybody and happy testing tomorrow. Bye-bye.